Okay. All right, everybody, we are starting. Ladies. Okay, so what did you decide makes a polynomial function versus not, Josie?
It has to be in standard form.
Okay. Does it have to be in standard form?
No. Well, I just noticed that most of those were.
But they are. Yeah, that would be the nice form. Did you notice something
It
else?
has to have like a whole number degree or exponent.
Degree or exponents, yes. Do you see all of the polynomial functions have integer values for their exponents?
Does the h of x equals x to the fifth of that?
Equals x to the, which one? Oh, well, it's actually 4/5.
Oh.
Yeah, sorry. It's a little bit difficult to see. Okay, so that was the big thing. Let me use that narrow one. Okay, so as you said, the exponents on the variables must be not just integer values, but also non-negative. So we'll say non-negative integer values. Okay, I'm going to add one other thing. The coefficients must be real numbers. Okay, so those are the big things. So if you'll notice, the ones that are not polynomial functions, we've got absolute values in there, we've got radicals in there, we have rational exponents, like that 4/5, and then in h of x, that's a division problem. Okay. And what's more about that division problem, because sometimes division problems can be restated, but in this case cannot be restated. As a polynomial. Okay. So we've actually been working with polynomials for a long time. So just officially, it's just the sum of monomials. So a monomial meaning we only have one term in there, and it just turns into a polynomial. Or actually, what's the other one we use frequently? Binomial. And we also use, when there's three terms, trinomial. We work with those a lot. And then usually anything after that we just refer to as a polynomial. We have talked about standard form. So this is sort of the generic form when we are in standard notation here. We've got a sub n times x to the nth power plus, and then we have the next coefficient. And then you'll notice that the exponent on the x is just decreasing by 1 until we get down to the last term, which is a constant, or you can also think of this as the x to the 0 term, because what is x to the 0? 1. No. No. No, it's just showing what the standard form.
Yeah.
Oh, the subscripts are like a position. The subscripts indicates more the position in the equation. Yeah.
Like a of 0 plus a of 1.
Yeah. So this is it's just the first term, and then we get down to finally the last term. So that's just a notation thing. It's nothing you have to really worry about. Okay, so the other thing we always want to pay attention to is what we call the degree of the polynomial. How do we establish the degree of a polynomial?
Yeah, exponent with the greatest value.
Okay, exponent with the greatest value. So determined by the exponent with the greatest value. And the other very important piece of a polynomial is the leading coefficient. Allison, what's that?
That's the coefficient in front of the degree.
In front of which degree?
The highest.
The highest degree, yes. So the coefficient with the highest degree exponent. And the reason those two pieces are so important is because they are the ones that pretty much dictate what the polynomial will do as you move away from 0 in both directions. And we'll talk more about that in just a little bit. All right, so before we get into those details, let's just take a look at a few examples here. See if I can move this down a little bit. Okay, so in our first one, well, in all of these, we're going to determine whether they are polynomial functions, and if they are, state the degree of it. All right, so in A, we've got 2 minus 3x to the 4th power. Would we say that is a polynomial function?
Yes.
Yes. What is the degree of this function?
4.
4.
Can we say 4? Can we say 4?
Either say of degree 4 or 4th degree. Just make sure that you indicate you are talking about the degree. Okay. All right.
Would the leading coefficient be negative 3 or just 3?
The leading coefficient is -3. Let's go ahead and write that in. It's not asking for it, but I'm going to abbreviate coefficient. -3. Okay. So how about in our next one? We have f of x equals the square root of x. Is that a polynomial function? No. So while it does have a radical sign, does anybody know what degree the square root is? 1. I heard somebody say it. It's 1/2. Now this is the same as x to the 1/2. And don't worry if you don't know that yet. We've got a whole section coming.
So why is it?
Well, so again, it comes down to the degree has to be a non-negative integer value. And this is not an integer value. Okay, how about in C? We've got x squared minus 2 over x cubed minus 1.
Well, you combine
Exactly.
them, then it's a sum of
Huh?
polynomial.
Well, if you look at it, that's just something you want to pay attention to. Can we restate this as a sum of monomials? Well, but can you divide x cubed into an x square? No, so there's no way to restate this. So this is going to be a no. Again, cannot be restated. Cannot be restated. All right. So how about in D? We've got x squared minus 2 over x cubed minus 1. Well, if you look at it, that's just something you want to pay attention to. Can we restate this as a sum of monomials? Well, but can you divide x cubed into an x square? No, so there's no way to restate this. So this is going to be a no. Again, cannot be restated. as a sum of monomials. How about D, g of x equals 8? Is that a polynomial?
It could be. No. It's not a sum of monomials. There's no x.
Okay, so it's not a...
But it could be a sum of them, though.
Okay.
It is.
Would we count it as a polynomial?
Because it's like that one.
Doesn't there have to be multiple?
Okay. It's like the one from... Well, I mean, technically polynomial would mean that there's multiple, but you also can have a monomial. And is this as a monomial? Would we consider it? Yes. Okay. What degree is this one? This is a... Okay, discuss. I hear two answers. Discuss with your... Okay, do we see an x value on there?
If it's 0, it would be 1. You would see the x. If it was 1, you'd see the x.
Okay, if it were a first degree, we would have to see this. We don't see that, so therefore that means this is an x to the 0 degree. So this is a 0 degree polynomial.
So is there no leading coefficient, or
The leading coefficient is 8.
8?
Yes.
Oh.
Lead coefficient of 8. Okay. So how about in E? We've got f of x equals negative 2x cubed times x minus 1 all of it squared. Is this a polynomial?
Yes.
Yes. Okay. So it's not in standard form, but could it be restated as a standard form? It can be. Okay. Okay. Nancy has already answered. It is a 5th degree. Does everybody see where that came from?
Yes.
Yes?
No. Oh, yes, because you multiply the whole thing.
Yeah. So what you want to keep in mind is if you expanded the x minus 1 squared, you would get an x squared out of it. And then you also have the x cubed from the beginning. And so together we get an x to the 5th.
The leading coefficient.
I thought it was always the highest.
Yes.
So why are we combining?
Well, because right now it's not stated as a sum of monomials, but we could expand everything and simplify. Alrighty. And Caroline already asked, but is it 2? Negative 2. There we go. Okay. All right. So this next part is an exploration. So I've got 8 equations. I would like you to graph them in your calculator and go ahead and make a sketch. It doesn't need to be a really detailed sketch, just a general sketch of what each of these looks like. Okay. And then once you have those down, discuss with your table mates things that you see that are in common, differences that you notice. Okay. And then we will discuss in a few minutes.
Oh, I'm like gonna graph it.
So let's talk about number 1. That's x squared. We've been working with that one. That's just a what?
Parabola.
It's just a parabola, and so it does something like this. Okay. How about with number 2? What happened with that one? Yep. Okay.
It was a weird.
It has kind of a...
They did not want symmetry.
No, it's not symmetric. I can't really draw well. It does something like that, and then... Okay. But what is it the two of them have in common? They are both opening upward. Okay.
And both arrows are going up.
Yes. Both open upward. Okay. How about in number 3, when we have an x cubed minus 5?
Is a line curve line.
Kind of like a
Sorry, I don't know how to describe
swiggle,
that.
something like that?
Well,
Okay.
Yeah.
All right. And how about in 4?
It's like that, but it's more narrow.
Okay. Does this one have a little dip? Something like that? I can't remember.
Wait, what?
Did that one?
Oh, both of them kind of do.
They both.
4 is less.
Oh, well, there's no like dip. It's
Three
just
has
like.
more of a defined
Okay.
curve.
So it's more of a, sorry, I can't remember. It just did this, but narrow. Okay, in general, what is happening?
When it is
It's a
even,
line.
if it's
Okay.
the thing where it's like, no, and when it's odd, it's like, here.
When the
that.
thing, the degree, yeah.
what Okay.
I agree
All right.
with that statement.
So I'm going to say ends go in opposite directions.
Oh.
Yes, that is a good way to describe it. I like it.
Hello.
All right. Okay, let's talk about in number 5 and 7. Okay, what happened in 5?
It was like
Again, what shape is that one going to be? That's a parabola again. Okay, so it should be symmetric. And then how about in 7?
it was like a curve.
Kind of a weird one. Looks almost flat here.
Yeah.
I'm doing that.
Gosh. That's not my life.
Okay. Alrighty. What do we notice about the two of them? They both open.
Down.
Okay.
Down.
Both ends open down.
Oh, these are positive and negative. I realize that.
Okay. All right. How about in 6 and 8?
They are
is the line.
snakes, but
Is it a line or
but they're
Yes.
like reflected, so they're coming from
It's
the
on
other
the negative.
direction.
other
Yeah.
direction?
Yes,
Okay. And
So
then
if
in
it's odd,
8.
it's a line type thing. Otherwise, it's big.
Okay. So what is it we know? So remember earlier I said we are always interested in the degree of the function, okay, and the leading coefficient, okay, and that's because those two things determine what the graph does at the end. Yes, Allison.
If the degree is even, both of the arrows are going to go up or down. And if the degree is odd, it's either going to be this or this. And if the leading coefficient is positive, it'll go up or it'll go like that. Or if or if it's negative, then it'll go down or it'll be the opposite.
Okay.
Thank you, Alice.
That's exactly what we are after. Okay, so again, there is some behavior that's happening close to 0, but again, it's the lead coefficient and the degree of the polynomial that determines the tails, or what we call the end behavior. Okay, so this is the big part that we are interested in. What is the end behavior of the graph? What happens as we move away from 0? And again, and that's dictated by the highest degree term and the lead coefficient. All right, so we use arrow notation when we are discussing the end behavior, right? So we would say as x goes to infinity, y goes to infinity, and that's going to happen when the graph is increasing on the right. Okay. Yes, so well, I'm going to put to the right, and we get this motion here.
Do you have a preference on which one to start with, like y or x? Or can we
You have to do the x first. Because
Say
you're again, we're looking to see what happens to y as x gets larger. Okay. we would say as x goes to infinity, y goes to negative infinity, and that's if, again, to the right, it is going downward.
That's normal.
Oh, sorry, I forgot the negative. Thank you.
Does the x need to be negative infinity too? Or is it just...
Well, right now we're just doing the positive. What's happening when we go to the right?
Would we draw that arrow at the end that's showing you other lines?
No, no, no.
Okay, so that's
No.
just
This is just,
okay.
I'll put these in parentheses because that's not something you have to write. Okay, so that's addressing the behavior when we go to the right. We're going to positive x. Okay, but we also want to consider what's happening in the negative direction. So we would say as x goes to negative infinity, y goes to positive infinity. And I'm going to say, so this comes from the left. We would have this behavior. And negative infinity from the left, it would be doing this.
So when they're both negative, x. Oh.
You're considering both directions. Okay, so let me put, this is going to be an or. You don't have both at the same time, or an or. Okay.
Oh.
Yeah, you don't have both at the same time. Okay. So let's do a couple. It'll make more sense as we look at an actual graph here. Okay, so in the very first one, actually first can you tell me, is that an even or an odd?
It's an odd.
It's an odd. Is it a positive or negative lead?
Negative.
It's a
Positive.
positive lead.
I tried.
Okay.
Because it's
All right, so again, we know that this is odd with a positive lead. Okay, and again, why do we know it's odd?
Because it's like it's not the arrows are not going in like both up or down.
Okay, so we'll say end behavior, opposite direction. Okay, and how do we know that it's positive?
Because it's going like when you like
Oh,
write
it's
your
traveling in the
name
positive direction.
Okay,
And that's just like the standard, like, or what's it called, parent function of like a cube.
of a
right?
cube.
Isn't it like?
Well, this one, yeah, this one's got more going on in it than the parent function. Yeah.
Without it being
Yes.
less.
Yeah, but again, we're looking at the end behavior of it. Okay, so what we would say for this one is, as x goes to positive infinity, so again, we're looking to the right. We're looking what's happening when x grows larger. Where is y going? It's going up towards positive infinity. Okay. And as x goes to negative infinity, now we're looking to the left. What direction? Y is going to negative infinity.
So in the test, you just draw the arrows.
Yeah, it's an arrow notation.
Oh. What is the top says odd, comma? What does that say?
Positive lead.
Oh.
So let's talk about the next one. Is it odd or even?
It is odd
This is odd, and again, how do we tell?
because
it goes downwards.
It's like opposite direction.
Yes, so end behavior, opposite directions. And is it positive or negative?
It is negative.
Negative. And we know that because
We know that because it's like going from up to down.
okay.
What does
And behavior. Right, is decreasing. Okay.
Odd and then it's also positive. She's just saying.
So we say as x goes to positive infinity, where is my y going?
Negative infinity.
Y goes to negative infinity. And as x goes to negative infinity, y is
goes to
going
positive infinity.
positive infinity. Okay.
For the you say it's negative lead,
Mhm.
right? Like it just down. Is it because it like starts in the positive direction and then it becomes negative?
You can think of it that way.
Like from left to right?
You can think of it that way.
But it doesn't matter what is up to down, or does it?
Well, if the other one
I
is
guess that
a
also
positive,
does it up to down or down to
that goes down to up.
Down to up.
Yeah.
Because that one goes from negative to
And that one goes-
negative to positive.
yeah.
If we look
And
backwards,
positive.
Yeah.
if we look backwards,
Uh-huh.
if we look backwards, how would we know like when to like turn around?
We don't necessarily. There's a few things we know, but we don't know necessarily. And we're going to look at something with that. Yes, Josie? Where?
I was like the parentheses that.
Negative. That my symbol for negative.
No,
You
no,
guys
the
don't know
one
that one?
next to it.
Lead.
Oh, it looked
Negative lead.
But yeah, like SUR, like negative.
Negative. Remember I told you guys?
negative sign to the side.
VE. Remember I told you guys I always abbreviate positive like this, and negative is abbreviated like this. Those are my abbreviations. Okay.
That means it's even.
Sorry, I picked that up from a professor many years ago. And it's stuck because it's quicker than writing positive and negative. Okay, let's look at the next one here. Is this one even or odd?
Even.
This is even, and again, how do we know?
Even because it's going the same direction as the
Okay, and behavior,
arrows going the
same direction.
Well, aren't they kind of going in separate directions? Because they're just going to continue on forever.
They do continue on forever, but we're talking about the same direction as in they're both going up. Say, how about that? Same direction in Y. Be a little more specific there. Okay, is this a positive or negative? Positive. Positive lead, and we know this because,
It opens up.
yes.
okay.
All right. Okay, so for the arrow notation for this one, I'm going to shortcut this a little bit because the y is going in the same direction. So I'm going to actually say as x goes to positive or negative infinity, where is y going?
Infinity.
Infinity. Positive infinity.
What about the little like pick up on the
Would you
bottom?
be allowed
Like,
to
do you
say
have to, like-
both?
Why?
Okay, but remember, we're after the end behavior.
No, I mean, do we like ever do something with that one?
We will.
Oh,
Yeah.
But wouldn't there be a missing gap in between those two because there's like the distance between?
What do you mean missing gap?
Because
It's going that way for x and it's going
they're both going positive for both positive and negative.
Oh, well, aren't those arrows going? It's negative.
No, but they're going in the same direction of y. They're both going to positive infinity. Positive. The y's are growing larger.
The y. Yeah, you gotta. I'm talking about the x's.
Yeah, the x's are different, but it doesn't. And we're talking about again the end behavior. Where does the graph end up as we move away from x equals 0? And in either direction, the further we get from 0, the graph continues to grow in the positive y direction. All right, and our last one, even or odd?
Even.
Even, and again, how do we know?
The arrows go in the same direction.
Same direction, and behavior in same direction. Okay, is it positive or negative?
It is negative.
It is negative
It opens down.
because it opens down. All right, so just like in the first one, because my y is going in the same direction, I'm also going to do this one as x goes to positive or negative infinity. Where is y going?
Negative infinity.
Negative infinity. All right. Okay, these next 4 I'm going to have you guys do on your own. So A and B are graphs, and then C and D are from the equations. So,
Just describe it just with the arrow notation, so you don't
Yeah.
need to do the rest.
nope. Okay, what did we find for the graph of A? As x goes to positive infinity, where is my y going?
It is going to negative.
Y goes to negative infinity. Forgot my negative sign. Okay. And as x goes to negative infinity, where is y going?
Positive infinity.
Okay. All right. How about in B? What's happening?
As e goes to plus or minus,
Like,
y goes to
Okay. All right. Okay. For C and D, did not give you the graph. You have to use the information that's given. Okay. For C, even or odd? Even.
it is even and it is positive.
Positive or negative?
Positive.
Look at the lead coefficient. What's the lead
Oh, I'm so sorry. I
coefficient?
thought you said B.
No, we're on C. What's the lead coefficient on C?
It is a negative. So
It's
it is
negative.
yes.
So, where do my two tails go?
They go in opposite direction. They go in the same direction.
And
They open negative.
down. Okay. Is that exactly what the graph looks like?
No.
No. Okay, don't get caught up on what's happening close to x equals 0. We're not concerned with that right now. We're only concerned with the end behavior. So for this one, we would say as x goes, since it's the same direction, we can do this, positive or negative infinity, y is going to negative infinity. Okay, what is the degree on D?
it is to the third.
It's a third degree.
Why didn't we? Were we supposed to let the degree for C?
No, I'm just doing this to. Okay, ladies, I need to make sure. Does everybody understand where third degree came from in D?
Yes. Yes.
Yes. Okay, so we've established its third degree, which means it is odd. Okay, which means the tails go in opposite directions. What is the lead coefficient, positive or negative?
It is positive.
Positive, which means we should be going this way. So, as x goes to positive infinity, where is y going?
Positive infinity.
Positive infinity. And as x goes to negative infinity, y is going to
Negative infinity.
negative infinity. Okay. What's that?
Why is the y going positive when x is going positive instead of y going negative?
Because it's a positive lead coefficient.
Oh.
Okay. Yes. Okay. Yeah. each of these x's is positive. This is a positive x. This is a positive x. That's a positive x. So if you multiply all three together, we're going to end up with a 1x cubed. Okay. All right. Let's do these last two together. Okay. I have h of x equals x cubed times x minus 1. What is the degree of this polynomial? Okay. This is a fourth degree, which is even or odd?
It is even.
It is even. Does it have a positive or negative lead?
It has a positive.
It has a positive lead, which means where are my tails going?
So the tails are going in the same direction upwards.
Same direction upwards. Okay. Is this what that graph looks like?
No.
No? I'm not concerned with what that graph looks like right now. I'm not going to spend time sketching it out all detailed because I'm only interested in the end behavior right now. So since I'm going in the same direction, I'm going to say as x goes to positive or negative infinity, where's my y going?
Positive infinity.
Positive infinity. Okay. And our last one, f of x equals x times x minus 2 squared times x plus 1.
Positive. I mean, it's going to be even.
Okay. How do we know it's even?
Because you multiply each squared and then you multiply times.
I have an x here, I have an x squared here, and I have an x here. Altogether, that's going to give me an x to the fourth, which again is even. Is there a positive or negative lead?
It is a positive.
It's a positive lead, which means my two tails are going
The other way. I mean, same thing.
Okay. Again, is this the sketch of the graph?
Nope.
No. Okay. Do I need a detailed sketch right now?
Nope.
No. I'm only after the end behavior. So, as x goes to positive or negative infinity, where is y going? Positive infinity. Okay, how are we feeling about end behavior? Pretty good. Let's see some thumbs. Are we here? Oh, I have everybody. That's awesome. Okay, good. All right, so this next part, this is on that little sheet of paper that I passed out to you. So these can be a little more challenging, but we are going to work through it. All right, so for these, it is asking us to sketch the graph of the polynomial with the features that it has provided for us. And then once we have that in, we use that information to determine what the degree of the function is and also what the leading coefficient is, okay? All right, so first thing I'm going to do is, I'm just going to go in order. The first bullet point is f is increasing when x is less than 4 and when x is less than 0 and x is greater than 4. What does it mean to be increasing?
Getting larger.
Getting larger, so it is going upward. Okay, so what I'm going to do is I'm going to mark off 0 here, and I'm also going to mark off 4. 1, 2, 3, 4. Okay, and we said it is increasing when x is less than 0. So I'm going to look to the left of 0, and I'm going to just put an up arrow here. That's telling me that the graph should be increasing. And also when x is greater than 4, so I'm going to come to the right of 4 and also draw a little up arrow here.
Wait, does it say it's decreasing?
On the next one.
The next one is decreasing.
All right. So the next bullet point says f is decreasing when x is where? In between 0 and 4. So now I'm going to draw a little down arrow here.
Why did you know that it's a down arrow to the right?
Because when we talk about increasing or decreasing, we're talking about, and just like we read from left to right, what's happening when we look from the left and move to the right. Okay, so that takes care of this part here. All right, so the next part, f of x is greater than 0. What does that mean?
Y is greater than 0.
Okay, y is greater than 0, which means y is going to be positive when x is between -2 and 3. So I'm going to come over here and I'm going to mark -2, and I'm also going to mark 3. And it says it is positive, greater than 0, when it's between those two values. So I'm going to just put a little plus mark up here to remind me I should be above the x-axis when I am between -2 and 3. But also when x is greater than 5. So I'm going to mark x equals 5 also. And greater than 5 is to the right. I'm going to put another plus sign over here. I should be above the x-axis.
Is this 5?
Huh?
Oh, for the second.
I'm still looking at this one here. Okay. The next bullet point, f of x is less than 0. What does that mean?
Below the x-axis.
Below the x-axis. When x is less than -2, so I'm going to come to the left of -2 and I'm going to put a little minus sign here. And when x is between 3 and 5. So between 3 and 5, I should be here. What does that mean about these points here that I marked?
It's gonna do a loop.
More than that. What's happening?
It's good. That's where it hits the x-axis.
Which are called the,
X-intercept.
those are the intercepts, okay? When do x-intercepts occur? Yeah, when the graph changes from a positive value to a negative value and the other way around, from a negative value to a positive value. So we've got our x-intercepts in now.
You start in the negative and then you draw up to it.
Yes.
Positive, negative, positive.
Okay, so again, on the left, I know that I need to go upward.
Oh, wait.
And then I'm changing. Now I'm going to be positive. And I keep going upward until when?
Until the very top. Which is the
No. Just
Look at the blue marks on top.
Until.
Why do you have to?
Oh,
why
until 0.
Until 0. Because what happens at 0?
You
Goes
switch.
down.
It's telling me the direction changes. So now I'm turning around and I'm going downward. And where am I going to go down to?
The next x-intercept.
The next x-intercept. Okay? And then what happens?
Go.
I go downward until when?
Until the next x at the top.
Until you hit that.
Okay, and that means I have to turn around again. And where should I go through?
You should go through 7,
X-intercept.
6, 5.
And then just go positive.
Wait.
Okay.
Does the slope have to be exact?
No. Do we have any idea what the y-intercept should be?
No.
No. Do I have any idea where I'm turning around? No. For all I know, this y value could be -100. I don't know. Is that what we are after?
No.
No.
Like for each part of it. Like so it could be really high.
It could be. I don't know. Again, I'm only after a general sketch so that I can figure out what the end behavior is. Okay, now I know that when you guys are working on paper, you usually only have one color. So one thing you can do is when you are showing where to change the direction, you can, you know, do a dotted line all the way down so that you see that you need to turn around when you get there. All right. So I just want to make a note up here. These first two, when f of x is increasing versus when f of x is decreasing, this tells you where to turn the graph around. Where the graph turns around. Okay. And this here, again, as we said, when y changes from positive to negative or negative to positive, indicates the, what are those special places called? The x-intercepts. Okay. Positive to negative, and vice versa. Okay. So it's asking us to describe the degree of the leading coefficient. Really, the only thing we can tell about this is whether it is even or odd, okay? So we could say, I'm going to add in here the least degree, because what is the least degree of this function? Yes. So we'd say the least degree is 3. Is the lead coefficient positive or negative?
It's positive.
Is positive. Okay, and for our end behavior, oops, I forgot to write as x goes to positive infinity, where is y going? Positive infinity. And as x goes to negative infinity, y goes to negative infinity. Oh, there was one other thing I forgot to mention earlier. One of the rules on graphs of polynomials, I'll just write this underneath. A polynomial of degree n may have up to n minus 1 turns. Okay. Okay. So if you think about a quadratic, which is a parabola, how many turns does a parabola have? 1, okay, because the degree is 2. Can a parabola have 2 turns in it? No. No. So that's what we're saying. The degree will tell you the maximum number of turns. And that's why I wanted to specify in this one, the least degree for this one is a 3. It's impossible for it to have been a 2. We know it has to be odd, but could it have been a 5th degree or a 7th degree? Yes, it could have been. So the least degree is 3 on this one. Yes?
Wait, I thought you said that a polynomial of degree n may have up to n minus 1.
N minus 1. 1 fewer. Yes.
Yeah, I was thinking.
It has 2 turns in it.
Oh, I was thinking intercepts.
Yeah. No, yeah. Turns, not intercepts. Yeah. Okay. I'm going to let you guys try the next one on your own.
Oh, that's really cool.
Yes, you can work together. Okay. There is the final sketch. Okay.
I did it.
Okay. And again, do we know what the actual y-intercept is?
No.
No. Do we know exactly where the graph turns around on the y?
No.
No, not after that. We're trying to get the end behavior. All right. So again, there were 3 intercepts here, so we know it has to be at least a 3rd degree. The tails are going in the opposite directions.
Like on the grass.
Oh, okay. Someone's probably going to be happy to find it. There's no name on it. So again, look at the end behavior and the directions it's going. Okay.